Hey everybody, how's it going? Did you have a good coffee break? A good conference so far? Cool. Well, in about a minute I'm going to be talking about another IoT prototyping session. And there'll be some live building and stuff. Should be fun. And we're going to be using Firebase and some other stuff. So might as well get started. Before I get into the details of the stuff, let me tell you a little bit about myself. Hi, I'm Jenny. I'm a developer advocate for Google. I work on cloud platform, which means I do silly things like this, and then I go back to work and try and convince them to keep paying me. And so far, so good. It's working great. But if you want to help me out, I always love seeing what cool stuff people are up to. So if this inspires you and you build something awesome, or you just want to ask me for help on anything, I love helping people out building stuff, feel free to reach out to me. You can find me on Twitter, Google+, usual places. Cool. So before I dig into the content, let me ask all of you some questions. There's some up here. But another one. How many? Was anyone here in the similar session yesterday at this very time, in this very room, 24 hours ago? OK. Only a few of you. So some of this will be a little bit of overlap. But hopefully you get something cool out of this. It was a great session. Hopefully this one will be fun too. Also, how many of you are electrical engineers or have a lot of electronics background? OK. A decent number of you. So I apologize now. I'm making a lot of oversimplifications. Because this talk is mostly for people who have kind of a pure software background. So I apologize now for all of the terrible sins I'm about to commit. You can talk to me, you can lecture me afterwards. But for everyone else, don't worry, it's fun. So how many of you know JavaScript better than C? OK, that's what I like to see. And this talk's for you. We'll be doing a lot of stuff in JavaScript that you might normally do in C, which is pretty cool. And how many of you have an Arduino or Raspberry Pi or some dev board gathering dust on a shelf in your house, not doing anything fun? OK, that's the real goal of this. We're going to fix that. Because what I'm going to do is I'm going to teach you kind of a recipe for building stuff that requires you to learn as little as possible, which means you can spend most of the time actually building something cool instead of learning background stuff. And here's the plan. So I'm going to spend a few minutes. This is the sins against electrical engineering I'm about to commit. We're going to do EE for web devs. So I'm going to talk through stuff and tell you, in practical terms, for your first day of hacking, just the bare minimum amount of electrical engineering you need to know. Then I'm going to share with you a recipe for kind of doing some building one of something Internet of Things device. So your first prototype, your first project, it's an IoT device. There are many other different recipes out there that are great. There are many other ways of solving these problems. This is just my favorite one, and it's a great one to get started with. Then I'm going to prove to you that this recipe works because I'm going to build something live in front of you, and then I'm going to write code to make it do something. And spoiler, it's going to be the hello world of IoT, which is a button that you press. It changes something on the internet, and then the internet changes because you just changed it, and then it lights up an LED on your board. So it's kind of like the hello world of electrical engineering, except IoT edition, so 21st century edition. And then with all the time left over, I'm going to do some silly demos, which are always fun. Cool. OK, so first, let's talk about some electrical engineering terms in web dev terms. So we write a lot of software, and when we write software, we deal with complex data structures and stuff. But at the end of the day, that all boils down to a bunch of ones and zeros, right? Cool. So in electrical engineering land, when you're building stuff with wires, it's a real physical world thing. There's actually current moving around and stuff. But you can kind of think about stuff in the way you're used to in software. We have things that are zeros, which is no voltage, also referred to as ground. We also have ones for digital systems, which is the high voltage of whatever we're working with. In this case, we're going to be working with an Arduino Uno, so it's 5 volts. And ones and zeros, that's what everything in software is made up of, right? So we're set. That's all we have. Easy. Kinda. There's a little more stuff we're going to have to deal with. We also have to deal with what's called analog signals, which is stuff that's in that hazy zone between a 1 and a 0, which is something you'll commonly see outputted from sensors or yeah, it's something you generally read from an outside system. And you're just going to kind of digitize that with something called an analog to digital converter and convert it into like lots of bits. Don't worry too much about that beautiful thing I wrote, I drew like in Photoshop in an airplane. But okay, one more kind of signal. There's this thing called PWM, which is short for pulse width modulation. You don't need to know what this means. There's actually like, this is a deep topic that just keeps on going down. Pulse width modulation is another kind of analog signal, except this one's usually used for output. And this is useful in cases where you have, specifically it was kind of invented, there's a lot of background oversimplification. It was invented for motors. Because as it turns out, like I might want to run a motor not at stop, I might want to run it somewhere between full speed and stop, right? But it turns out if I use like an analog signal, like just the physics of a motor does not like that. So the solution was just go back and forth really fast. So if you spend half the time at the top and half the time at the bottom, you essentially have halfway in between. And like there's some complex math behind this, but it keeps your motors from catching on fire. That's all you really need to remember. Is PWM is basically analog output, but it's not really an analog signal. Like if you hook a multimeter up to it, it's going to look a little bit wonky. Okay, so there's like kind of the basics of the signals we're going to be playing with. You don't really need to remember them in a lot of detail, just that they exist and their terms. Okay, so now let's switch over to my little cam, which I'm going to do right now. And we are going to kind of take a tour of the components we're going to use to build kind of our first project. And these are kind of, you can kind of think of them like Legos, except sometimes they catch on fire, which is like, it's bad, but it's not that bad. Like you get over it after a while. I'm going to fire up QuickTime, see if it will cooperate with me. Woohoo, it did. Okay, that's just my test thing on Arduino, which we'll be talking about. But before we get to Arduinos, because they're complex, let's talk about some simpler things. Okay, let's talk about wires. Here is what's called a jumper wire. Here's another shorter jumper wire. One of these is kind of a pre-made one that I bought in a little kit, and the other is just a piece of solid core wire that I cut and stripped the ends off of. Wires are how we're going to move our signals around. So if you think about like a circuit 101, like you just connect a wire to two places and then it kind of connects it and the signal passes over the wire. Okay, enough said. Just got to cover that real quick. Next component we're going to be dealing with when we build things is this thing is called a solderless breadboard. How many of you have used a breadboard before? A lot of people. Okay, so for those of you that didn't raise your hand, a breadboard is this thing that you can plug wires into so you can connect them without actually like soldering them or something like that. And the way they work, thankfully I found a clear breadboard, is they kind of have these little clips that they connect wires. And they connect them in a couple different ways. They have these channels that kind of go up and down. So if I take this part off, they're also like Legos, and I put two wires into this channel on the side, this whole channel all the way down is connected. So these two wires are not connected to each other. And breadboards are really cool because like it's a really fast way to move wires in and out. Like I just connected two wires and really fast. I can unplug them like that. There are also these horizontal channels. They have a little gap in the middle. And they also connect, except they connect horizontally. So if I plug a wire into the same row, they're going to be connected. And the reason there's a trough there is if you have an integrated circuit, which we won't be dealing with too much today, they can kind of span that. But you're going to see components that kind of like go over it sometimes. You're going to see that come up. So there's a little IC that spans it. But don't worry about that too much. Just realize that there's a gap in between that doesn't connect. So you have a breadboard, which is how you kind of do like the experimenting. It's kind of the whiteboard of electronics. Then if you want to move on to kind of like, okay, so I got it working right now, and I actually want to be able to move it off my table without it falling apart. There are these cool things which are called a perf board, stands for perforation, or proto board. They come in all sorts of flavors. This is a more basic one. It just has a bunch of holes, and you'll like use a soldering iron to connect them. But I actually love these guys, which is one I got from a website called Adafruit, which if you look at it, looks just like the breadboard, which is great because I don't really have to think. I just take the thing I had in the breadboard, copy it over, and then solder a few things, and it's done. I don't need to like think about the wiring at all. I just copy, which is a lot easier than doing original thought. And then I can save my original thought effort for something else. So these are great. They're great for building that one of something. So you'll see I use these things a lot. Okay, enough with just components that are plugging into each other. Let's talk about some other stuff that we're going to use to build our circuit. Here's this thing called a resistor. Does it show up there? Okay, so there are these resistors. The way you can think about a resistor is it's just a really, really bad wire. Get the exposure right. And so this is useful in situations, all sorts of situations. Like this is an incredibly useful component for electrical engineering stuff, but we don't really care. As far as we're concerned, for the first day of hacking, there's only one kind of resistor. It is a 10K ohm resistor, and it will come up in what's called a pull-up or a pull-down situation. And these resistors have these little like barcodes on them you can learn to read. But I just go and keep them in little baggies with the number written there, which is fine. And since we only really have to deal with 10K ohm resistors for now, like there's only one kind, so don't worry about it. So get some resistors, put a label on it, learn the stripey code later. Another thing is a button. Buttons are cool. It is a simple component. They're kind of two little pins sticking out of each side. When the button's sitting there not being pressed, they're not connecting. So those two things are not connected. They will not pass a signal. When I push it down, those two wires are connected and they will push a signal. Simple. But oops, one of the legs fell off. That button is now dead. One more component. Actually, let's do a couple more. So this is a light emitting diode. It is essentially a light bulb, except it is directional. If you notice, one of the little feet is longer than the other one. The longer foot goes to high voltage, and then the little one goes to 0 or ground. When you do that, when you have them both at, when you have 5 on one side and 0 on the other, it will turn on. If they're both at 5, it won't turn on. If they're both at 0, it won't turn on. It's a light bulb. Yay, we'll be using those. Two more components I just want to show you that are a little more sophisticated. That we won't be using too much, but I just want to illustrate to you that they exist. This is called a potentiometer. It is a dial. So it is an example of one of those analog inputs I was talking about. And the way it works is you put like a reference high, like power, on one pin. So like 5 volts on one pin, ground on the other pin, and then the middle pin will be the ratio of how much you've turned. So you turn all the way one way and it'll be 0. Turn all the way the other way and it'll be logic 1, 5 volts. In the middle, it'll be about 2.5, which is really cool for kind of analog inputs. And like, what might you want to use an analog input for? Like, how about the reverse? This is called a servo motor, which is essentially the exact same thing backwards. So it has 3 pins again. One of those goes to like reference 0. One goes to reference 1. Actually, this one, the pins are in a different order. They each have like their own reference guide. So like reference 0, reference 1, and then a signal. And if the signal is a pulse width modulation, because it's a motor, and the pulse width modulation is at half, it'll go to about the halfway position. If you give it like full signal, it'll go all the way one way, and full ground, it'll go all the way the other way. These are really cool for doing all sorts of things. Like I zip tie them to things all the time and use it to like push buttons and stuff like that. They're really fun. They're actually tiny little microcontrollers in them, which is pretty cool. Okay, so that's enough of kind of like the primitive components, our simple Legos. But we got some really cool super duper Legos too that we're also going to play with, that I'll take a moment to discuss. This is one of the things I can use in my recipe. It is an Arduino Uno. It is the most basic and original of the Arduinos. This is actually it's open source, like open source design. This is actually a knockoff that I got because I buy a lot of these. You probably already have one of these. If not, they're really cheap, which is cool. And they're also incredibly durable. You can do terrible things to them, and they very rarely catch on fire, which is awesome. Because a lot of other dev boards out there do catch on fire. Like especially the ones that come from the manufacturers themselves, like the chip manufacturers, which is pretty cool. So like the thing about a microcontroller that you have to realize, it is kind of a dumb device. It has a chip on it that is the microcontroller chip that will run your code, but that's about it. It doesn't have an operating system, so you're running your code on the silicon, which means you don't have like an internet stack. You don't have threads. You don't have virtual memory. You don't have all those cool things we're used to in like Linux land or any real operating system. But the flip side is you don't have to worry about timing, about interrupts messing up your stuff. Like if you say like do something and then wait a second and do something, it'll run really good timing. Like it'll work pretty well, especially if you like attach a real-time clock. But that's a future topic. And it has a bunch of different inputs that are like, as I mentioned, it's durable. You can feed it all sorts of nasty signals, but like. There's a few different inputs that can read different things. Like let's look over here. It's kind of like reference pins. There's like a little one that says 5 volt. It's a little out of focus. Let me give it another try. You can do it. There we go. You can almost legible. There it is, 5 volt. It says 5V. That's kind of, think about it as your reference 1. You can also draw a little bit of power out of it. Then there's a couple ground pins, and you can think of those as reference 0. There's a bunch of these pins that have an A next to them. Those are analog inputs. That's how we read analog signals. Those are generally input only. Then on this side, we have our digital pins, which are cool. They're how we both read, or you can put them in either read mode or a write mode. And you can either write out a digital signal or read a digital signal. And there's special ones with little tildes next to them. The squiggle means that it can output a pulse width modulation signal, which is pretty cool. It has this hardware PWM, which means you can say like write half, and it'll do in hardware, it'll do it for you like magic, which is really cool. We have one other board that's going to come up. It is the other board that's like ubiquitous in hackerland, which is the Raspberry Pi. This is a Raspberry Pi 2, but there are a whole bunch of them out there, A, B, B+. They're all pretty similar. They are tiny little computers, and that's all we're going to use it as. It is a computer. It has an operating system. Most people run like Raspberry or other flavors of Linux on it, but you can run anything that'll run on ARM. Like I've heard of people running like ARM Windows builds and stuff. They're really cool. It's a computer, but as a computer, it has like computerish like upsides and downsides. Like it has an operating system, so we get an internet stack for free. We don't have to kind of like hack out packets by hand, which is crazy. We have like USB ports and network ports, and we can put little like network USB plugs in there, and they work. It has HDMI output. It's cool. And we'll be using this for kind of like high-level stuff, like higher running stuff. And what's cool is you can use these things together, which is what I'm going to get to next. OK, so those are all kind of like the Legos of our little Lego experiment we're going to be doing. Let's get back to the slides for a sec. So there they are. There are components. Sometimes they catch fire. Don't be afraid when it happens. Hopefully not too often. Cool. OK. So here is the recipe that I use for a lot of my projects, just because it's easy and I already have the stuff lying around. There are many other recipes. There are many other ways you can solve problems. One of kind of the core ideas of this recipe is we're trying to push our problem solving into a space we are familiar with, which is JavaScript. So I realize a lot of the things we can solve with like component, like integrated circuits, or like with the electrical engineering, or with the C layer. We're going to be pushing all of the hard work down to JavaScript because that's what we're familiar with, and that's where we're going to be most productive. So kind of from the bottom up, we have our components, those things I just showed you. Resistors, transistors, all that stuff, Raspberry Pis. And those are going to, there's our Arduino Uno. So we're going to plug our components into our Arduino Uno, our buttons and potentiometers and stuff, which is great because like the Arduino Uno can handle lots of like terrible stuff. Then we're going to use this awesome library called Johnny5. It is a JavaScript library for interacting with all sorts of electronics boards. There are a whole bunch of other options out there. Johnny5 is my favorite for reasons I'll explain in a minute. But there's great ones too out there like Cylon.js and stuff. They're all awesome. They all have strengths and less strong parts. Then we are going to take some kind of computer that can connect to the internet. And this will be the internet part of our Internet of Things. And we're going to use that to communicate with the Uno. So if you were building something small, I would use a Raspberry Pi. For development, you can use your laptop, which makes your dev cycle so much faster. And you spend a lot less time dealing with like network and stuff. Because Raspberry Pi is like when it's a little independent device, it's a little independent device. It's hard to log into sometimes. And then we have the internet part is because Johnny5 is a Node.js library. So because it's Node.js, we can use anything else that will work in JavaScript land. And one of those things that I like to use is Firebase. Because full disclosure, Firebase is part of Google Cloud Platform. But it's cool. It's a really fun thing to use. So we've already talked about some parts of that recipe. I'm going to dive into a couple more in detail, Johnny5 and Firebase. Johnny5 is a JavaScript library. It's a Node.js library for doing electronic stuff, mostly targeted at robots. It has this really cute mascot from a movie long, long ago. Does anyone remember the movie? Short. Yes, it was a great movie. I love it. So we are going to look at Johnny5's web page, which is a GitHub page like you might expect. Oh, there's code and files and stuff, and a giant logo of Johnny5. Not a huge surprise. But this is where it gets cool. Like a bunch of names of boards it supports and stuff. The documentation for Johnny5 is stunning. Because like for all these different components, they have basically the same documentation format. They have a picture of what you make your stuff look like. So you just take that picture and then make your board look like the picture. And then it has code that interacts with that picture. So what you can do is just like those Legos, you take your Lego, you find the thing you want to use, and there's a big list of components here. So let's say we want to do a button. We go down, oh, there's all sorts of components. There's a LiDAR in here, just like a laser radar. There's all sorts of cool stuff in Johnny5 now. And there's a picture of the circuit you need to build. So you make your breadboard look like that. and then you paste in this code, and it runs, and you're done with that component. And you can really go from page to page, take code and diagrams for different parts, and kind of squish them all together, which is pretty cool, and make your thing. So that's why I recommend Jenny 5, especially to get started. So the other part I want to talk a little about is Firebase. How many of you here are familiar with Firebase? A lot of people. Cool. So Firebase, one way to think of Firebase is it is kind of this big bag of goodies that you can use to make your app dev easier, like mobile app dev or web app dev. And it has a whole bunch of stuff that makes that easier. Like we have this thing, this real-time database. We have like authentication that makes OAuth much less annoying. We have static hosting. But I'm going to focus on one tiny part of that, is just the real-time database. And actually, we're just going to use a tiny subset of the features of the real-time database. Because the way you can think of the real-time database is it's a giant ball of JSON in the sky. And you can write to specific paths in that JSON. And you can also listen to either paths in that big ball of JSON or queries against like paths or subtrees. And what happens is when those things change, if you have a listener on it, we will just call a function in your code, which is cool because it simplifies a lot of the concurrency issues and stuff. It just kind of works. And we're going to be using a tiny subset of even that. But just to give you an idea of the kinds of things you can build with this and why I think it's cool for these kinds of projects is here's something that was written with like 100-ish lines of code. Did anyone take Muni in today? Was your bus on time? It's always kind of. But here's an example of where all the buses are around us in San Francisco about 100 milliseconds ago. You can see they're kind of moving. Most of them are not. I swear, this is live data. They're just actually stopped. And this is written with like 100-ish lines of code on one of our open data sets, which is cool. You see it move around. It's always fun. Sometimes I pop this up when I'm waiting for the bus. Where are you, bus? And this is an example of data that, like, if it's an hour old, like where the bus was an hour ago, not very useful. But data, like where the bus is right now that I'm waiting for, is super useful. Here's another example, real-time collaboration. This is an interactive slide. If anyone has like a laptop handy, I haven't added touch controls to it yet. You can go to firesketch.firebaseapp.com, and we can like work together to draw something cool, which is fun. And I always try and draw a dinosaur. I'm not very good at it though. So who's using it in the audience? No one ever owns up to. Oh, there, yeah. Is it fast? It's pretty responsive. Cool. OK, so that's just a couple examples of like app dev you can do. Oh, also, no, my dinosaur. Oh, it was one of the best ones I ever did. OK, so to give you an idea of how you interact with this. So we're just using a tiny slice, and here's some JavaScript code that I just copied and pasted from the web quick start. Is when you connect to Firebase, you refer to a Firebase via a URL. You can also use like stuff afterwards to refer to subpaths. If you want to write to it, you just use set. There's some other methods for writing too, but we're only going to use set today. So I just want to set, hey, developers. If I want to read, I set up a listener, just like like doing like a click listener, except I'm doing a value listener on a path in that Firebase. Then I get this snapshot back that is this immutable copy of the data with a bunch of associated metadata. We're not going to care about any of that. We just want to get the data out. In this case, we're just logging it. Cool. OK, so enough stuff, enough pre-work. Let's actually build something. How about that? Sound good? All right, let's build something. This is usually where the demo gods make fun stuff happen. Bring up my little Projectomat again. New movie recording. Let me make this big so you can see my stubby fingers assemble components, which is real. OK, so what we are going to be working with today is an Arduino. I have a little Arduino with a little breadboard next to it. Just make stuff a little faster. I'm going to move a bunch of stuff out of the way. And we are going to build the hello world of IoT I mentioned, which is a button that changes something on the internet. And the first thing we're going to do is, like an Arduino comes out of the box, just like it has a bootloader on it, but it doesn't really run any code. And the first thing we're going to do is we're going to add some special software to the Arduino, which is the only kind of C code we're going to have to interact with, which is a special language that allows Johnny 5 to talk to it called Fermata. And Fermata is cool because it's already part of the Arduino IDE. This is the beautiful Arduino IDE, which is great and accessible, but kind of ugly. but we all love it. When you want to put Fermata on your Arduino, the first thing you do is plug it into USB. And then Fermata is part of the Arduino SDK. It's mysteriously in the examples area, and it's a weird thing to be an example. But we're going to use standard Fermata. So you open it up, and there's a whole bunch of code in here, and it's actually pretty straightforward. Like, someday, I've tweaked it a couple times to add functionality. But we don't need to do that. That's not what we're up to today. Today, we're just going to write that to our Arduino, which usually requires fiddling a little bit. So I'm going to tell it stuff it already knows. I have an Uno. I am programming it over USB, and I'm using an Arduino thingamajig. OK, let's see. And telling it what it already knew worked. So I just written Fermata to it. And now I can close my Arduino IDE, and we don't have to open it again. The Arduino now knows how to talk to Johnny 5. Yay! OK. So what we're going to do is we are going to build a button that interacts with the internet. And we already have a picture here, which I'm pretty much just going to copy and kind of talk you through what I'm doing as I do it. So first thing I'm going to do is I'm going to get a couple long jumper wires in colors that make sense, like brown and red. And I'm going to take those reference highs and reference lows from over here. I'm using the brown pin to represent low. I'm going to plug it into this vertical rail. Because there's a reason that little rail goes all the way up and down, is it is a great place to put your reference high and your reference low, your ground and your power. Cool. So there we go. So I have the little red wire carrying high and the brown wire carrying low, which is kind of the convention I use. Then we're going to get a button. Let's do the light first. Let's grab an LED. I'll grab a green LED, because coincidentally, green LEDs don't burn out when you give them 5 volts, which is nice. And I'm going to plug it in with the long pin towards the top, which is cool. So now I have an LED plugged in with the long pin up at the top. And I'm going to give it that reference low I mentioned. I'm going to hook it up to ground. So I'm going to grab another blue or brown wire. I've got a blue one. And I'm going to connect the short pin to ground. And then I'm going to take that longer pin, and I'm going to connect it to, so I want to be able to control this from my Arduino. So I'm going to plug it into one of the digital outputs. I don't need PWM for this, so I'll just use pin 2, because why not? And make this bend so it doesn't block everything else to do. So there, the LED, the high pin, is plugged into pin 2. Let's make it work. So I'm going to go over to my handy dandy console. Snippets folder. OK. So I'm going to use Vim. Yay.js. And Vim, of course, the best editor ever. You never need anything unless something only existed in the Emacs plugin, which comes up. So I'll make it a little bigger. All right. So as I mentioned, we're just going to kind of do some copying and pasting. Let me go back to grab that code for the LED. Let's go to the real article. It's a little bit less compressed. There we go. We have an LED. We're going to make it blink. I'm going to go to a directory that already has, I have to like npm install stuff, but I don't want to make you sit through that. So I'm going to go to a directory that already has Johnny 5 installed and Firebase installed with npm. So there we go. This is the code from there. This is something we'll be doing a lot. We'll be changing the pin from the example. We're using pin 2. All the examples have this REPL stuff, which is useful. What it allows you to do is interact with the interactive console. Like you can actually like type while it's running and make it do stuff. We don't need that. We just want it to blink. We're going to run, yay, and let's see if it works. Just to verify that like everything in the stack is working, we just pasted in some code, and we're going to run it. It's taking a little second looking for connected device, but you're right there. So doing the typical thing, we unplug, we plug back in. Wait a few seconds. Oh, there it goes. So it's blinking. It doesn't really show up great. So now we're at the point where we have a thing. It's doing something. That's cool. But we want the button to do it. We just don't want it to sit there and blink. So it's going to go, and we're going to combine stuff from this page and the other page. So the next thing we're going to do is we're going to put that button circuit together. Oh, and if you notice the LED's on, sometimes it's better to do your electrical work with stuff unplugged, because like for MATA, like if you just cut it off, it'll just stay where it was. In that case, it was with the LED on. So you might have current flowing through, which is a recipe for things getting hot. So here it is. There's a little button. It's not doing anything. It's just hanging out now. And the circuit's going to be very similar to the last one. We're going to, what we want to do is we want to read the high state from, read our reference high from the button. So what I'm going to do is I'm going to take the top pin and I'm going to wire it into reference high. So now the button is like, just the top is at high, the bottom is just hanging out. We're going to take the other one and, didn't realize it was bumping the microphone. We're going to take this and we're going to plug it into a pin we're going to read from. Why not pin 4? Pin 4 sounds good. So there we go. We have pin 4 we're reading from. Yay! Okay. And but there is a problem with this circuit, and the problem is that so like right now, if the button is pressed, what it does is the button connects those two wires, and I have high going through the red wire, through the white wire back to the Arduino. That's cool, right? I'm going to read a high. Everything's going to be happy. When I let go of the button, I've opened up that circuit. Like there's no more place for electrons to go. So the red wire is still going to be high. It's going to be 5 volt. The white wire is just kind of hanging out there, and there's like seriously charge just sitting there that the Arduino's like trying to just keep an eye on, but not really influence, and it's going to cause the Arduino to kind of freak out because it'll take a little while for those electrons to escape via entropy, I guess. And just the the amount of that is drawing to do the read. So our solution to that is, remember that resistor that I said you only really need to worry about 10K ohm resistors? We're going to invoke one of those. We're going to do what's called a pull-down resistor, which is something you probably need if your thing is kind of like flipping out between 1 and 0 a lot. And what this does is, as I mentioned, it's a terrible wire, right? So it's a terrible wire in that when I release the button, it's going to slowly drain the rest of the electrons. And by slow, like it'll happen really like in a millisecond. But it's more, it's less resistance than like leaking it out through your Arduino. So the current's going to go that way. And that's why, like in this picture, you see that pull-down resistor, which is the same resistance. Cool. OK, so now we have a button wired up to pin 4. It's pin 4, right? Yep. And we have some code. Let's copy this code, which we don't need all of it because we already have some of this stuff. I'm just going to copy the button thing. Where did my BIM session go? Here it is. We're going to do a button. It's on pin 4. And we're going to add some listeners to it. Up and hold and up. Let's just do up and down. There we go. We're going to do an up listener and a down listener. And we're going to take the LED state and we're going to tie it to that. And we're going to turn the LED, when the button is down, we're going to turn the LED on. When the button is up, we're going to turn it off. Not on, off. All right, let's run Node, see if it works. So we have Node, we have this pile of wires, and oh, my Arduino's not plugged in because I was doing better practices than I usually do. And I see 3 lines there. It looks like it's probably on. So if I take that button and I press it, nothing happens. And that's because these buttons don't always reach all the way down into the little breadboard and don't make that connection sometimes. So what we can do is we can take these wires and we can just actually wedge them into the same little hole the button's using. These are the kinds of debugging you have to do with circuits sometimes. And it is angry. Why are you angry? Maybe I need a bigger resistor. And by bigger, I mean physically bigger. Same value, just with thicker wires, because the little one might not be making enough contact to pull it down. OK. So it thinks it's down. It's pin 4. OK. This is where I'd probably get out my multimeter usually. Boop. Let's take a look at the code again to make sure there's no problems there. So button is up, button on up, button on down. OK. Let's give it another kick. and hope for the best. Otherwise, we're going to be using wires to simulate the fact that there's a button there. OK, so we're going to pretend this button, go away. We're just going to be doing this like old school, just by plugging wires in and out. Because you have been, OK. So what we're going to do is if it is, oh, it's this row of the breadboard, isn't it? There we go. Yeah, this is the kind of fidgeting you get to do with electronics, is that you're dealing with a real system with real things in it, like electrons and stuff like that. So you actually get to spend a lot of time doing debugging that you know is a little bit less abstract than the debugging we do in web dev land, which is cool. It's kind of fun. And it does not want, the button does not want to work, but we can simulate it just by plugging wires in and out. So the equivalent of the button press down is moving the wire and putting it in the same row. The LED turns on. Moving it out of that row, the LED turns off. So we have a really super manual button because my physical buttons are not cooperating. But we'll move on. So we just built the thing, but it's just a thing still. It doesn't have any internet yet. Let's add some internet. And I'm going to continue my barrage of copy pasting by going to Firebase, the Firebase docs. I'll just go to firebase.com, click on docs. As I mentioned, web. We're not really using web, but JavaScript is awesome that way. We can just go to the web quick start and we can copy the Node.js stuff and paste it right into the same thing, in the same file. So we have Firebase. I already npm installed it. We're going to connect to a Firebase. Might as well connect after the board is ready. I'm going to call it ref for easierness. If Firebase is referred to by URL, I'm going to do this cool trick where if you add -demo, it creates a Firebase on the fly. So you don't need an account or anything. You can just create a Firebase on the fly, which is cool for doing quick hacking. Although anyone can write to it. So if you connect to this, you can write to it. But don't monkey with it too much right now, please. And then what we can do is we want to write when the button goes up and down. So I'm just going to copy the little set instruction from the tutorial. So this is just where it says how to write data. I just copied and pasted it. We're going to write to that same location. Actually, let's do the button location. So I'm going to write to this Firebase in the path button. And I'm going to write when the button goes down, I will write the word down. When the button goes up, I will write the word, not that, up. And then I want to take the LED and we're going to use the internet to control it instead of the button. So we're going to take that out. So now when the button goes up and down, or the wire connects and disconnects, we're just going to write word up or down to the Firebase. Reading data, we're going to create a little listener. I'm going to copy the sample code here, which I can simplify because we're not doing navigation down. We already have that button. Renamed it to ref. We're not going to alert because why? We're going to log. First, before we do that, var equals snap dot val. If it is down, if it is up. If it is down, we're going to turn the LED on. If it is up, we're going to turn it off, or if it's anything but down. OK, so we just did a quick Firebase thing. We wrote a value. We read a single value, just using a small set of what is available there. But it is enough for us to do our hello internet world thing. So let's run that same script again. Let's take this Firebase and look at it in the little database viewer, which has values in there because maybe I practiced. If we go back to our circuit, let me just make these all nice and visible and take this, put it down here. So you can see all the different things happening at once, even though things are a lot smaller than they were just a minute ago because I made them smaller. So if I take that thing and I connect those wires simulating a button down, the word down gets written, the LED turns on. If I disconnect them, the thing says Firebase set up, up. The cool thing is, because it's attached to the internet, now I can use changes to this little web console to make the LED turn on and off, which is pretty neat. So there we have the hello world of the Internet of Things. And the other thing that's cool is if we have multiple, oh, I see someone poking it from the far internet world. If you were to, like, for example, make another one of these, like the slightly more polished version, I put in a little box so it didn't shake apart when I travel. And I moved the Node.js code to a Raspberry Pi that I also have hiding in here. I have a little wireless button that I can use to turn it on and off from a distance, which means two of these things together implement one of the most overcomplicated telegraphs ever created, which is pretty cool. And back to slides. So we built something, and so we have a few minutes left. So, oh yeah, so we made the Hello World Electronics. Silly demos, and the first demo is, of course, what could you do with a button? Well, my slide deck is also written in JavaScript, so I can use the same Firebase code to interact with it. So if you hit the button, you can do things like rickroll your slides. So you can make this change, but this is just the beginning. You can actually make these buttons change anything in the world that you could connect to the internet. So even though it's just a hello world, it's still totally useful, I swear. Oh, someone said mean things. But see, I've gone like a year with doing these things, and no one's ever been mean except one of you. But remember this demo from before, the silly sketch thing? Oh, thank you. Someone's crossing it out. I built this little device with a couple potentiometers on it, those little dials I talked about earlier. And I took that demo and I made, it's hard to tell, but I essentially made an Etch-a-Sketch. So the light green, the kind of teal that's being drawn right now, is by turning these little dials. So you can build things, and this is just based on the same kind of development model I did before, where I just took things out of the Johnny 5 docs, pasted them in, and then I just kind of like tidied it up so I could put it in the little box. And that's it. Like you can build really cool things with these. I've done other things like, put servos on hungry hippos and make it play the game and all that kind of stuff. But yeah, you can do a lot of cool stuff with it. Okay. So in the last couple remaining seconds, let me tell you some parting words. So first of all, wasn't that easy? There was not a ton of code in there. And none of these demos have code either. I think this little Etch-a-Sketch thing is like 40 lines of code. And the button's like the 10 lines you already saw. The other thing is let projects guide your hacking. So like a lot of us went out and we bought a bunch of dev boards because we thought they were cool, but we didn't have any specific projects in mind. So I really encourage you to think of something you want to accomplish first. You can find inspiration all over the web, and like use that to guide you and try and solve that problem. Like for me, one of the things I tried to do was making hungry hippos internet connected. It kind of worked out, but I learned a lot along the way. Oops. The other one is feel free to experiment. Like I said, these things will catch on fire sometimes. Like it's going to happen. It's OK. You'll survive. Keep a fire extinguisher handy. And feel free to experiment. Another thing I love to do is to take things apart. So I'll buy like old industrial electronics or stuff from the 80s off of eBay and just take it apart to see how it works. And I've learned tons from that too. And that'll help bridge the gap to future projects. And you get all sorts of cool components out of it. Like I got these really nice potentiometers from like a 1970s video mixing board, which is pretty neat. Oh yeah, and of course, like things will catch on fire eventually. Don't be afraid. And celebrate the first time the magic blue smoke comes out of your electronics. And that is it. So go build some cool stuff and tell me about it. The code from this talk is up there on my GitHub. Feel free to go up there and poke it. I'll be moving it into a more permanent repository. It's just kind of my snippet repo now. But yeah, go build cool stuff.